Hi everybody, hope this video finds you all well. So what we have here, some of you may already know, and some of you may not. This is a SAE, Scientific Audio Electronics, and they're a company that made high-end audio equipment back in the 70s and 80s for the most part. And this is a Mark VIb FM stereo tuner, and it's very unique and it has quite the following. And I can tell you, I've gone through this one already, and absolutely beautiful condition. There is probably nothing that I'm going to have to do to it, and really the only thing we're going to do is maybe a little bit of a show and tell video, as well as we're going to go through some of the alignments, not to align it but just to verify them, because I'm pretty confident that this thing has been properly aligned. It's been fully restored. I was a little bit taken by surprise by the amount of work that was done on this receiver, or this tuner, because when I got inside, you're going to see there were a lot of transistors replaced, a lot of capacitors replaced, and even a little modification was done. So we'll go through all that and look at it. But here's the unique thing, and this is what makes this thing so popular and such a novelty item. And you can see, yep, Nixie tubes. Our favorite displays, huh? And on top of that, just like some of the Marantz equipment that we've had, it has a scope in it. It has an oscilloscope, and you can see, you can switch it between FM, so you can actually look at the multipath. It has the audio, where it just kind of gives you the dancing pattern to the audio. And it even allows you to put an external X and Y. It works almost like an XY scope. So you can put an external signal in there. So it's all pretty cool stuff. Now the only one thing I could find with this thing, and it may have something to do with some of the mods that were done on this, is that the mono and stereo selector switch doesn't seem to have any effect. So if you look right now, we're tuned in to 94.5 FM. It is a stereo station. And if I switch to mono, you can see it doesn't switch over. And what's more, you can hear the stereo separation still, even when this switches into mono. So I don't know if this function was disabled, or or was modified, or what, or if that's just the way this thing works. I'm not sure. But I can definitely still hear the stereo. Now, this was a pretty high-end tuner in its day. It was really expensive, and looking at the schematic, and I do have a good set of schematics for it, it's a very well-designed tuner, and it's called a digital tuner, but it really isn't. That's kind of a little bit of a false advertisement. It does have a digital numeric display for the frequency, but it's just using kind of a frequency counter and putting it onto the display like that. It still has an analog tuning gang. Everything's analog. There's no synthesizer in it or anything. It's still using just a standard oscillator mixer circuit. Even the multiplex is not using much in the line of integrated circuits. There are some. This thing does have a couple of op amps, but really most of the integrated circuits in this thing has to do with the digital display, but really not with much of anything else. So it is very much an analog tuner, but it's very high quality. It does have an RF amplifier section, so it is relatively sensitive, and it does have a very, very, very warm sound. It reminds me a lot of the Macintosh MR71 that we had on the bench here, which is one of my favorite tuners as far as sound is concerned. So even though it's all solid state, it does have a very vacuum tube-like sound. It does have some pretty neat features. It does have both a fixed and a variable output. The variable is switch controlled. It's not a pot. There's a tuning threshold where I think this has something to do with the sensitivity of the muting circuit. However, again, a lot of that seems to this just kind of works, and some of these controls don't have a whole lot of effect. They have some effect. So there's a stereo filter, and I'm sure that has something to do with the multiplex. Other than that, it's a very simple tuner. There's not much to it. We can kind of move the traces around, and we can focus and intensity and so forth. But by and large, that's it. And you can hear it.
The survey to number 23, that's I Can't Wait by Stevie Nicks.
And that's mono.
Starting an esports tournament.
You can see when it gets to a stereo station.
Check us out on Facebook.
There's a stereo station. So it seems to be, I mean, it's very, very selective. The adjacent signal rejection on this thing is really amazing for something that's all analog. And that's one of the things that impresses me about it the most. So anyhow, now you kind of see what it is. Let's open it up and take a look inside. So before we start talking about this, I should mention that YouTube channel Techmoan, Techmoan. If you haven't subscribed to his channel, I highly recommend it. Fantastic, very, very entertaining, very good, informative channel. He did a video on one of these that he purchased, and it went into a lot more detail than I have here about it, and kind of shows you how it works and everything. Very neat video, so check it out if you get a chance. And I do believe it's his personal collection, so the one he purchased I think he still has and still uses, and you can learn more about the history of this and so forth through him. I think he does much better job than I ever would, so I highly recommend it. And if I remember, I'll try to post the link to his video in the notes section there, comments section. Okay, after looking at the schematics a little bit, here's the layout of this thing. So down here you have your display board, and the whole purpose of this, with all these integrated circuits and everything, and by the way, this is treated just like an invisible box. They don't show you any of the schematics for this. You do get schematics for everything else, but the display module they do not give you. But the whole purpose of this is just to decode this is nothing but a frequency counter. So all it does is you have your RF coming in here, and it actually is using the oscillator, and I'll show you that later. So it's actually using the oscillator circuit and then decoding that and then displaying it on the numeric display of the Nixie tubes. So this is nothing but a frequency counter that's kind of been offset a little bit to display the actual tuned frequency. Now, I'm not sure why they did it that way, but on the schematic at least it appears to be that. We'll look at that a little closer here in a little bit. Now, over here it kind of took me a little while to look at it and figure out what they were doing. But really this section here, let's start at the beginning here. Right here's your tuning gang. And on top of the tuning gang, you'll see these little transistors here. And actually, they're not all transistors, but there's a little 2-channel JFET in here. And I'm not sure where that is on this module. And then there's this chip right here, which is your I'm off the camera again, ain't I? Hold on. Okay. Let's start over again. So this is your front end of your tuner. So you have your tuning gang, and your oscillator are all in here. So your RF and your oscillator is in here, along with the adjustments for it. It comes out of there and it goes into a dual channel JFET, which is your oscillator circuit. And then the oscillator comes out of that JFET and it goes into this little IC right here. And this is a differential amplifier IC. And this is your RF amp and your mixer circuit all in one. So not only does it amplify the signal, but it also mixes it with your oscillator. So when it comes out of here, it's already coming out as an IF frequency, as your 10.7 megahertz. Comes out of there and then goes into this module right here. Let me back you up a little bit. This is actually your, well, you can't really call this just the IF section, because this board does more than that. This right here is your discriminator coil, and this looks very familiar, doesn't it? But in addition to that, this is your IF amplifier circuit, your limiter circuit. So I think this chip here is the limiter. And what is a limiter? It strips off all of the AM components of your FM signal. And the reason that it does that is to eliminate static. That's the whole purpose, is you want to take all of the AM noise out. So that's what your limiter circuit does. Then after you're done with your limiter circuit, it actually will get decoded into an AM, once again, a clean AM signal. That's kind of how an FM tuner works. So anyway, that being said, so this is your limiter, goes through all this stuff here, and this is where it gets interesting. This circuitry down here, not only is it your detector circuit, so your discriminator detector circuit, and we'll get into that here and later, but it also is your pilot detect circuit, and they don't call it that in this. So let's look at the schematic. This is really interesting. So first of all, I kind of had to enlarge the front end of this thing. So there's your tuning gang that we talked about. Here's your little dual channel JFET, and here's your RF amplifier / mixer chip. And I don't know why they're calling this a 74S112. This is actually a CA 3053 chip, I'm pretty sure. If you look down here, it is a 3053. And so anyway, so that's it right down there. And then you can see I kind of drew this. Here's your oscillator circuit, or your oscillator signal, and it kind of takes this path and it goes into pin 5, which is your low input, which is your oscillator. I kind of drew this here just for my own remind me. So this is your oscillator, and then here's your RF coming out up here, and I did that in yellow, and it goes into pin 1, which is the high input. So you have high input and low input, and this is where it mixes the two signals. And when it comes out of here, this blue signal, now you have your 10.7 megahertz. Then it goes through a filter, and it goes up into your first IF amplifier, which is another 3053 amplifier chip. And then that goes through some more filtering, and then into that limiter circuit. You see, first 4-stage limiter. And then from there, it goes into another IF circuit, I'm pretty sure. And this is where it starts getting strange. When we get up to here, let me move the camera again. And again, don't take what I'm saying as the end-all be-all. I'm kind of figuring this out still as I go along. But it comes out of here, and you see I kind of circled this stereo threshold. This is where it's actually detecting the pilot signal somehow. And again, I'm not sure how we're doing this, because you also have this scope top adjust, and you have some strange things here. And then you have your muting circuit in here as well. And you have a mute threshold, your side muting balance, and your side mute sensitivity. So the muting circuit is very complicated in this, how it works. And then there's also like an FM stereo filter circuit, which is down below. So really a different type of design altogether. The problem is there's no procedure with this. There never was, to my understanding. This schematic is really everything all in one, and it's all the information anybody has on these. So really this is going to be a little bit of trial and error, and I'm going to be very careful to mark the position of all these potentiometers so that we can put them back. Luckily they're just single turn pots. We can put a little tick mark where they are right now, and if we get in trouble we can put everything back to how it was. But I really believe this is where our problem is, in here somewhere. So I have my work cut out for me. I'm going to look at this a little more carefully, and when I see how this all works, then I'll come back and I'll share with you what I found. So sure enough, it was just an adjustment, and now you can see I'm on auto or stereo. If I go to mono mode, now it switches back and forth. Now, here's the thing. If you listen, that's a very weak signal, and the muting circuit, you know, will mute it out if you turn muting on, even with the threshold, no matter where you adjust it. And that's how it's supposed to work. So, and they do interact. And here's all it was this little potentiometer right here. It just needed a little adjustment off of, you could see the little red paint mark where it originally was, and it just needed a tiny little adjustment. So for starters, we're going to use old reliable here, our 8657 signal generator. And to test, the first test I want to do is 50 dB quieting, which I normally don't officially do this test, because after you do enough of these enough times, you kind of can pick up with your ear and with your scope and everything. You know when the thing's dialed in and when it's not. If people want to see numbers, you can do the tests and get the numerical values, but really I'm going to do it by the book this time just to show you all. So what you see right now is I have a carrier signal of 98.1 megahertz. And I'm outputting an amplitude of about 30 microvolts. Now you have to understand this microvolts, we're feeding it out of a signal generator that has a 50 ohm impedance, meaning this display is only accurate when you apply a 50 ohm load to it. Now remember, commercial grade, consumer grade FM tuners have an input impedance of 75 ohms. So you're either going to have to do math formulas to convert it, which we can do, and I even have little charts in order to do that. I even have a spreadsheet that does that, or we can use our little matching L network, which I'm pretty sure you've seen this. I've done it in videos before. So we're gonna set this up. Now, I have kind of an easy way to do this. You can do it with measuring the RMS voltage, but if you have a meter that can directly measure decibels of change, it's a lot easier. So the first thing we're going to do is we're going to start out measuring the millivolts. Now this is the millivolts of actual noise, and this is a true RMS meter, so it can pick up the noise roughly. This is your noise floor with a 30 microvolt carrier. And if I turn on the dB meter, it's going to do reference to that noise floor, and it's going to bounce around between 0, plus and minus 2 dB, which is fine. We don't care. Now what we're going to do is we're going to turn on the FM modulation. So we have 99% modulation, 1 kilohertz tone, and we're going to look at this, and you can see we have 37 decibels of difference. Okay, so the name of the game is to adjust this until you get 50 dB, and it can bounce around depending on, even like putting my hand over the tuner or anything can affect this a little bit. It's a very sensitive test. So we're going to go back off, and we're going to go back up here, and we're going to increase this just a little bit. So let's say we'll take this to 40 microvolts, okay? And we're going to go over here, and we notice our noise level has changed. It's gone down. So what we want to do is we want to go ahead and re-zero this. And you can see it's off by a little bit. Let's try it again. Right there. That's pretty close. And it's going to bounce around. There's nothing you can do about that. So whatever we put in there now, we have to add. You can see it kind of moves around because these tuners, they just generally pick up noise. And we're going to turn on our signal. And you can see it's about 45, 47. So we're going to keep doing this until we get 50 dB. That's the name of the game. Okay, we're at about 49, and we're floating at about -1 plus, you know, it kind of floats around. So right there is your 50 dB quieting. Okay, so what that means, that's your signal to noise ratio. In other words, there's a 50 dB difference between the signal with just the noise by itself, you know, just the carrier, and the carrier with the modulation. And you can see we're at about 45 microvolts, which is high. It should really only be somewhere between 20 and 35, something 25 to 35 normally is where you'll see it. Now, there's a lot of things that can play into this. Number one, if I look down here, look at what my signal's doing. This is just the oscilloscope of the other channel. Both channels are doing the same thing. See what's happening to my modulation? And take a look down here as that's happening. See it? This will start to go out, and eventually the stereo light will kick on when it shouldn't. See it? There it goes. And I don't know if you can hear that. See that? I'm not doing anything. So this should never change. Now it's one thing if the muting circuit, you know, kind of drops the signal out, but it should never give you a stereo indication. And that's what this thing's doing, especially when you have this thing set for mono. So even though the receiver is sensitive, the multiplex circuit in here is affecting it. So we're going to have to try to figure out what's going on with the multiplex on this thing. So as much as I thought this thing was perfect, because I'll tell you what, if you just listen to a station, it sounds beautiful. But what this tells us is that when you have a weak signal, it could definitely still have this problem with the multiplex. So I'm going to look into it a little more. Now, more scary is the next problem here I'm going to show you. Okay, let's move you over here where you can see. And this is my new SG80, and don't mind the wires, they're kind of in the way right now. But the thing I want you to focus on really is down here. This is nice. This has a direct 75 ohm output. So no L network, no matching pad, nothing. I can just use the direct cable that came with it, go directly into the 75 ohm input of the tuner, and everything is supposed to read directly. Now, I'll show you where I'm at right now with this. If you notice where I have the knob set, take a quick look, and we're going to go over here and we're going to do our little test again. And we're going to just re-zero this. Okay, and now I'm going to turn on my carrier. And you can see it's a little bit low, so I really actually need to turn this up even more. And the scary thing is, and you can see how much noise there is down here on the signal. And if I turn it up, okay. And if I look down here, my stereo signal's on. So this whole thing's going crazy. But more importantly, if you remember, even with that multiplex problem that we're having with the tuner, we weren't far from where we needed to be. You know, the difference between 25, 30 microvolts and 40 microvolts is really not a whole lot. But if you look here, I'm set at the times 100 range, which is from 27 to 270 microvolts. And if you look at where my knob is right here, I'm between 100 microvolts and 150, so I'm at about 140 microvolts. So it's off by 100 microvolts compared to my known good test equipment. I think this thing has been worked on. I don't know. When I received it, it looked mint. It looked brand new. And I never touched anything in it. But I also never went through and really tested it. I'm going to have to do some work on this before we're going to use this on any videos. And in the meantime, we're going to use our old standby, our 8657. So I was just ready to call this thing a wrap, and all of a sudden my problem with the mono and stereo switch started to come back. And don't worry about that, that's a weak station. But here's a good station that's nice and strong. See, now we have stereo, and if I flip this, mono, stereo. And it took me a minute to figure it out, so I started looking at the schematics at the actual switch. I thought maybe something was weird over here. As it turns out, there is a wire that goes all the way over to here, and where the heck is it? Well, I'll show you on the thing where it is. Right down in here. I don't know if it's going to focus. It looks, yeah, it's focusing. Right down in here, this little green wire had fallen off. It was laying on the terminal, but it was falling off. And if you wiggled it, it would just quit working. That's the mono select wire. And you can see from all the work that had been done on this amplifier, you see all these little terminal tie points. And let me back up so it focuses a little more. These are all push-on terminals, every one of them. Some of them have been soldered, some of them have not. And somebody had removed all of these to replace these transistors and service this at some point. And a lot of these were loose. So I ended up having to tighten those on there, and it cured that problem. So this is a really good example of the simpler things sometimes are the problem. And you don't need to get too complicated, other than looking at the obvious when you're troubleshooting these things. So I'm going to leave this stuff in the video because I think it's really important to see this, that you can have some problems that look really complicated, but the fix for them can be relatively simple. So this tuner is working absolutely flawlessly now. And, another thing I noticed about this is really interesting. It's the way it's designed. If you look over here and you have your mono, auto, and stereo. Auto means it'll just toggle between the stereo and mono mode based on the strength of the signal, which is we adjusted with that little adjustment. But if you flip this on mono, just like you would expect, it goes to mono. But the cool thing is if you flip it to stereo, if you do not receive a stereo station, it will mute the channel out until the station comes in stereo. If there's no pilot tone, you will not get the station, even though you're tuned into it. So it has to be on auto. So this would be only if you want to tune in stereo stations only that are strong enough to trip the pilot and give you a stereo station. Really interesting. Again, this is the first time I've worked on one of these Mark VIs, but the more I work on it, the more fascinating it is how they designed this thing. You got to remember, this was something like 1972 or something like that. This is a really old tuner. And of course, there's no phase lock loop on the Multiplex, nothing like that. All analog circuitry and super sensitive, and the thing really works well. So we'll do a quick tuning sweep. I mean, we know how sensitive it is now. All right, we have this all put together. I've gone through the whole thing and verified all of the voltages and all of the alignments and everything on this. And I want you to listen to this beautiful sound. I'm going to take the microphone off my shirt here for a minute, and I'm going to hold it by the speaker. Do you hear that beautiful staticky 400 hertz sound? Do you know why I'm happy even with the static? I'm happy for two reasons. Reason number one, if we focus in on our Sencor SG80, I'm on ×1, and I am on, you're looking at it, a half a microvolt. And remember, you're going to ask yourself, well, I thought you said this thing was way off and reading low. Well, you know, this is a good time for me to not take this off of the video, to leave it in there for a good example for all of you. You know, I always tell people at work, always look for the simplest problem first when you're troubleshooting an issue. And of course, I made a few comments that perhaps the Sencor is out of alignment as far as the output is concerned. And really, that had nothing to do with it. You can see here's my normal little 75 ohm cable with the little ballon in the back here. And the actual problem was the interface cable that came with this SG80. It does not work properly. That's all it was the cable. So back to basics, you know, when you're having a problem, what's the simplest thing to look at? So believe it or not, this receiver is actually picking up a a tiny teeny little all it is a 0.5 microvolt signal. So this thing is extremely sensitive. Now, the other thing I'm wondering after I found this out is I may be able to set the threshold back up a little bit on the stereo and mono adjustment. So I'm going to check that. But after that, I think this tuner is just absolutely working perfectly. And I think we're going to be ready to get this one off the bench. And just one last thing, I want to show you the 50 dB quieting level. And if you listen, right now, here's our output. If I turn the amp on, you hear that? You can barely hear it, right? And you can see where I'm nulled out at the noise. If I turn on my modulation, 50.9. So I'm actually a wee little bit over it. And you can hear that's with the modulation. Now, here is the amazing thing. Now that I have that, I don't have the defective cable in there. Look at where we're at. We're on ×10 or 20 dBF range. I'm sitting at 10 microvolts or just over 30 dB or 30 dBF. Very good. That's really where you wanted it to be. Like I said, we want it to be somewhere in that 25 to 35 dBF range. There it is. So again, this thing is perfect. So I'm quite happy. Okay, let's go through this thing and see if we can listen to some stations. I'm going to turn it off this channel a little bit so I don't. All kinds of stuff here. There we go.
At times, the opposite occurs.
And you can see with the tuning. Now this is set for checking for deviation. Or multipath. I'm sorry, this is for checking multipath. And you can see when you're centered on the channel, see how that arc is centered? If I tune off of it, it goes to one channel or the other. And there it just kicked into stereo. Very nice.
Businesses that are still open. A lot of restaurants.
Mind you, this is down in the basement.
Cheese, Doritos, Locos, Tacos.
Thanks for the way that you feel.
Loaded it. This thing, so now all I can do is just talk to him.
See how high it is right there? This is a very strong station right here. There's another medium strong one. This one's not quite as strong. See how it's lower? But it's still stereo. Now here's the weird thing. See how that's on stereo? If I go to stereo only, that's fine. And mono. But let's see if I can find one that's just mono. So now see how this is in mono? If I switch this to stereo, it drops it out. And you can see this is a totally flat line. It's not curved. There's no multiplex there. Now I'm a little tiny bit off station, but this is an example of how this works. If it's in auto, it'll tune the station regardless if it's a stereo or a mono station. Pretty cool how that works, huh? There's that.
A what? Workman. And that's not a guy behind a desk with a tie and...
So, long story short, it works, and it works perfectly. Let's recap. So first of all, this knob wasn't working properly, and it was because that wire was loose. The stereo pilot wasn't kicking in when it was supposed to, and it was just slightly, the threshold was just slightly out of adjustment. So little tiny touch to that brought it right in. All the other voltages and settings, and by the way, there is no alignment guide with this, but if you look here, they give you, some adjustments like what they want. Like right here, when it's in stereo mode, they want 12 volts. Or I'm sorry, signal is 12 volts. When there's no signal, they want 3 volts. And if you check on that little brown wire there, that's exactly what you get. And that's how this thing works. And that's kind of the alignment guide is built into here. You can see all these little test points and you can measure them all. So this thing's lined up. I mean, it's all of those numbers lined up where they were supposed to. So that's good stuff. So this tuner is going to probably grace somebody's stereo rack, which is great. And hey, I'm happy. So as always, I wish you all peace, joy, happiness, and good health. Lots of good health these days. And I have some more things coming that I'm really excited. I want to let you know I have another SAE system, and it's a complete system. It's an integrated amplifier, tuner, and tape deck. And we're going to do those eventually. And it's from 1977, and it actually was my brother-in-law's. And I remember when he bought it in 77, brand new. It was a very expensive system with a set of RTR tower speakers and a really nice Rotel turntable. All very good stuff. But anyway, we'll get to that one day. It's on the list. So that's it for now, and more videos to come. And like I said, I'll hold out and try to put out as many videos as I can with the free time I'm getting, but eventually this is going to pile up, and we're going to get really busy at work as things start loosening up in the hospitals. So you may see my video output drop down at that time. But until then, I wish you all well, and I thank you all for your comments and for all of your donations and all the wonderful things that you've contributed to the comments and so forth. And take care and stay well. Bye-bye.